Hello and welcome to the Aruba Restful Automation Series. This is episode 2. We're going to talk all about APIs. I'm Rick Kaufman, Global TME from the Enablement team here at Aruba Networks. Now let's dive into this subject. APIs, what are they? What are they good for? Well, just about everything we're going to come across in a data center is going to have a RESTful API where we can use this uniform interface to communicate between all the different disparate things we can find. We can get information from one and put it into another one, all using a higher level programming language like Python, which we're going to focus on in this series. Now, we have Roy T. Fielding to thank for all this. He was the guy that coined the RESTful API in his dissertation. He was the co-founder, or still is the co-founder of the Apache Software Foundation. He was co-developer of the Apache web server that is like 80% of the web servers used in the world today. This guy is super bad, and I was super curious to figure out who he was, and it was great to go out there and do a little reading on this particular subject. Now, Roy T. Fielding, I thought I heard that name before from my past. And when I looked, I thought it was this. But this guy's really Roy Fleming, not Fielding. That's my Mandela effect moment for the day. So, APIs through history. We have SOAP APIs. They were popular for a while. I don't see them a lot. RPC's been around forever. People still use it widely. And WebSocket APIs let us have this callback functionality. So if we're monitoring some agent or something like that, we can get continual updates. And then, of course, there's REST APIs. And that's what we're going to focus on here. So when we're talking to a REST API, this is a note of caution. Do not try to write your software so you handle all the interaction with the API in your code. There's a ton of that code that you're going to write that you're going to use with some other app that could be used with some other app. So we want to abstract that code out of what we write and have some sort of library that we can use to load into Python. I love Python. It's extensible this way. But we want to make what's called a binding or a Python library that we can import into our code and save us a whole ton of software development, right? And where do we find these bindings? We can find them out on PyPy.org, also known as the Cheese Shop, and it's super easy to install. So if we say pip3 install PiCentral, that'll get this Python library, our Python binding, and it will put it in our Python development environment. Now that it's in our environment, we can actually leverage the code that's in the PiCentral binding and import that into our code, and it's just like we wrote it all. So, but it's like pre-written package that we just install in our application, and we have access to all of its functionality. This is going to save you a ton of time developing, and all you have to do is import PiCentral, and you have all of the power of PiCentral now in your script. So when we look at the anatomy of an API, now this is a particular Python binding. So this is an endpoint that I'm going to use in my code to talk to an endpoint in an actual API running on another software system somewhere. And you can see that in these endpoints, there's a bunch of code that we wrote in here, a bunch of checks, and all this stuff you don't have to do now because you imported this into your Python script. So all the heavy lifting of formatting the URL the proper way and applying the headers and the authentication and actually having the communication with the API is all done by this binding. So it really abstracts that and makes it a lot easier, and that's what we want to do. We want to do things the easy way, and that's what happens when we use these bindings. Now, we're going to pass some parameters here. The URL we pass, we're going to feed down into this URL string we're building. Now, all this looks all scary and stuff. Don't worry about it because we're going to cover this inside and out. But I'm just showing you how this stuff works. Here's a whole string base URL that I don't have to write 100 times in 100 different scripts. I can just do it once and import this into my code. You can see it's doing this for me, building this whole URL string for the full URL, applying the authentication, adding the parameters that are optional, and then I'm using another Python library called requests to actually do a HTTP GET verb on this particular endpoint. Okay? And so now I'm going to see some sort of response come back from that request. And you can see I'm using response equals request.get. Well, now all that stuff that came back is now hiding inside the word response. And if I dig into that, I see some sub things that I can query, like response.status code. And we all know what status codes are. We saw those in the introductory video in episode 1, but we're going to dive into that a little more. But I got a 200, and 200 usually means good things happened. It says, oh, I'm going to make a variable called device details, and I'm going to go get response.text, JSONify it, and put it into the dev details, and I'm simply going to return dev details and a very particular key called device. Okay, if that happens, I'm happy. If not, great sadness in the world. So these status codes, there's a bunch of them. And don't worry, I'm just teasing you. You don't have to memorize these. But they're basically in groups of numbers, 400s, 500s, 200s, right? The good news is, I love this return code 418. I'm not a teapot. That's cool. But the good news is, I'm sorry, this is a bit of an eye chart. The good news is level 200, level 400, level 500. That's all I particularly am concerned with in what I do. You may find others, but these are the most popular ones I find. 200 basically means you're all right. Sometimes there's remote cases where it couldn't be that, but 99% of the time it means you did something right. 400 is you did something wrong. You got your authentication wrong, you got your URL endpoint wrong, or there's something wrong in your code, but it's you. You did something wrong, and we're going to experience this here in the lab. And then 500 is, it's not you, right? So you can complain as loudly as you want. So if you want to try out some of these status codes, be my guest, httpstat.us. You can go out there and play with this all day long and get all different types of return codes back and see what they look like, and maybe you might use them. It might be a good training thing for how to handle different types of return codes when you start writing code. Just a heads up there. HTTP verbs, on the other hand, there's like 9 of them or so. You can go out there and read all about them here on this link, but we're not going to use all of them. We're going to use like 3 of them: the get, post, and delete. So we're going to say, can I have this please? Can you create this please? Or can you delete this please? And if we have those 3 HTTP verbs, we can create, read, update, and delete like a Mongo database record. Very powerful. But as always, we have to prove who we are before we can access the endpoint that we want to get to. So we're going to have some HTTP authentication. This usually happens in the HTTP header. Here's a little chart, shows I'm looking for something. I get a 401. I'm unauthorized. So I need to provide my credentials or my token or whatever it is. And once it gets authenticated in some backend server, then I'm free to go. I'll get my 200 back, or if I didn't use the right stuff, I'll get a 401 back. So when I talk about HTTP authentication, there's a ton of it, not a ton, but there's quite a few. If you want to know, here's a link at the bottom. Be my guest, knock yourself out. But we're going to focus on bearer authentication or token authentication. And if we get a chance, we'll talk about session. Session authentication is a little different. They give you a session key, and it's stored in a cookie. And that cookie just gets passed back and forth. And whenever I talk about cookies, I have to have a picture like this to visualize the cookie. And remember, the stateful information that's going back and forth is tracked in these cookies, and it kind of mimics being a stateful protocol when in all actuality HTTP is a stateless protocol. So we use cookies to try to maintain some sort of state. Okay, let's move into the demo. Now the demo is going to be a little bit lengthy because we're going to cover a lot of stuff, but it's really basic stuff. So hang in there with me and let's get started. Okay, let's get started with the demo portion. We have got a little application that I wrote, and we're going to look at it and explore it and see really how this stuff all works. Now, out on my GitHub is the repository for this API 101. GitHub is a place that you can save the stuff, the code you write, out on the internet and track its version and control, and then also share it with other developers. That's what we do. We share, get a GitHub account. But once you have a GitHub account and you want to put something into GitHub or get something out of GitHub, then you're going to need the GitHub client, and that client is right here. So you can go out here on this link and just Google installing Git, follow the rules, and you too will have a Git client. You can say GIT, or GIT rather, and you can see Git is working here on my desktop. So I want to work in a directory called opt. So you're going to make a directory called opt, right? But I already have one, so I'm just going to change directory to opt. And you can see this is where I do all my development, right? So we're going to go and clone that repository from GitHub. And we're going to use the git client and the git clone command, and we're going to give it the URL of the github.com/xod442 slash API underscore 101.git. And that will copy what was out on my GitHub and bring down all these files, and we'll have them available here to work on. Well, first of all, we need to change the opt or into the directory API 101, and now we can see that we have our files all here. Okay, so now we're going to run this Python script. I'm using the editor here from the Atom editor, so I can open up this directory and I can see all the files we downloaded when we clone them. And we can run this app. Now this app is super simple, and this is all it is. As a matter of fact, if we took away the endpoint, this would be a complete web server running in FLASK. FLASK is a web framework written for Python, and this is how easy it is to get a web server running in FLASK. This isn't production stuff, but this is for our development efforts. So we go V here, put the endpoint back in, and we can see that in FLASK, we can bind URLs to a route. And then if anybody puts that particular URL in their browser, it will come here, and if it's just the URL itself, it hits this entry point here where it says slash, and it runs this function called welcome, and it returns this string. That's all this endpoint is doing. So to get that to run, we're going to want to run that particular application, and I'm going to do it in Docker. Now don't worry, we're going to run Docker Desktop, and all of our Docker functions and our Docker Compose functions are all handled by this. It runs on Mac, Windows, and Linux. Just go Google it, install Docker Desktop. Now once we get Docker Desktop running, we can say Docker Compose up-d, and that will bring up the application inside the Docker file. And it just does that because we have a Docker Compose file that tells it to build a web server, and we have the Docker file that describes what goes in the web server. So it's just going to copy everything. Well, it's actually just going to work off the local directory here, but it's going to run FLASK 5000 the Docker Compose will offer 5,000 to the 5004 for our web browser. So if we look, it says it ran, so that means we can go to just 5004 slash is what our entry is, and that's what we get back. It worked. So our little API over here in this app py file actually worked. So we said slash, and we got the string back. That was the greeting that we wanted to return. Now, what if we want to take this a step further and give it another route? And this time, we want to call that route name. And then I would have to put name in like this to collect the name from the URL. Down here, I want to collect the name or assign the name into the function called name. Nothing crazy going on here. And I like the welcome. And I'm just going to come over here and put this thing called a %s, which is just a placeholder for a string, a Python string, right? So that's just some characters. That's super basic. And we're going to say this purple % in there, and we're going to give it the variable name. So every time it sees the variable name, or whatever's in those parentheses, it will put them in the %s. This is string formatting in Python. I'm not here to teach you Python. I'm here to teach you how to use Python. So there's many great courses on Udemy for Python. So we're going to return the string. So what do you think is going to happen now? We save this file, and we come over to our browser, and we manipulate this URL to say slash name, and I like the word Gorthos. That's a cool name. And it does exactly what we told it to do. It took the name we gave it from the URL, and it put it into the function, and the function used it to return this string. Simple. Okay, now we're going to take it one more step further. And all we're doing is just manipulating this URL to drive us to a different place in the application. And let's put one in called add, and we're going to say like that. Boom. We're going to say arg1. I like that. And then we say arg2. Now down here we're going to collect arg1 and arg2, and we're going to call this function add. But I don't like the welcome anymore. We're going to change this to sum equals arg1 plus arg2, and then we're going to return the word sum. Now it should work, right? I think it will. So let's find out if it does. We're going to give it the route of add, and then we say add here, and then we say, oh, this is good, 8 and 6. So we're going to add the numbers 8 and 6 together. And that's worked perfectly, right? Not quite, because all it did, it took 8 and 6 and stuck them together with a plus sign. So what we're seeing here is that arg1 and 2 are not numbers that we can do a mathematical operation on. They're strings, and we need to convert them using this little Python called int. Boom. And we take what's ever inside the parentheses and turn it into a number so we can do a mathematical operation. So yeah, that's going to work perfectly, right? So let's give it another try. And if we do that, yeah, we get a problem. And this is why I like working in FLASK. Because in FLASK, it will come back and really give you a lot of great descriptions about what's going on. And you can even open up the command window and actually be inside your script and be able to put in little things to help you debug along the way. It's an awesome environment to work in. But this tells us that the string, or the return type, must be a string, a dictionary, a list, a tuple. But what it got back was an integer. So in our code, we converted the strings to integers to add them together. So Sum is a number, but we're returning a number here, but we have to return a string. So we have to kind of do the opposite here. We have to say your string now. And now it can get returned properly. So we'll go back and try it again. And that's how it looks. Yeah, it worked exactly like we want. Now, we have another app up here under answers that has all this other stuff in it. So we can go out and past the add, we can grab the subtract API and go all the way through here and grab all this. Don't grab that last line. We can copy, and then we can come over here into our original app and just add to it. Remember, we have to be all the way over to the left, and we're going to add to it, and we can say, oh, this is cool. This is going to work because we now have these endpoints that are going to go out to Google and talk to Google for us. So this is awesome. Let's go ahead and try this route called Google One and see what happens. Well, when we try Google One, that didn't happen for us. And one of the problems is that we're using this thing called requests, and if we go up here, we didn't import it. So we didn't import requests into our function or into our script. So we're going to go ahead and save that. And if this doesn't work, I'm going to have to figure out why. Let's see if our app's still up. Our app is still up. And add still works. Add still works. But when we go to Google 1, oh, there we go. You gotta spell Google right. I found out that the more you spell it correctly, the more it works. So what happened was we went out and hit this Google One endpoint, and it went out to Google, and what it did was it broke down and returned the status code. And this is what we were dealing with earlier when we looked at status codes. And what status code did we get? 200. And we all know that 200s are smiley faces. So I think we did okay there. It did what it was supposed to do. But what if we wanted to return other portions of that result? Now, result has a bunch of stuff that is basically behind it that you can query. And so this one, we're going to query the URL string. So if we go up to Google 2, say Google 2, thank you. It does exactly what it's supposed to do. So this is a really basic example of how APIs work. And this is really what we're going to do a lot of. One more hip tip, I like to give a little bit more information in my script so when people come back and read them later, they know what the script is about. And I just kind of put that here between the triple ticks. And now I can put in here my name or whatever I want. So people come back and look at this later. They know the licensing and they know how to get a hold of the person that wrote the script. Okay, that wraps up the demo. Now I want you to know if you're going through this and you have some sort of error message or something doesn't look right, well, simply take that and paste it into Google and search. Because I'll guarantee you, you're not the first person to have that problem. I have already had it. So there's answers out there to just about every single problem you have. Always, always Google the error message. It'll help you out immensely. And if you're developing specifically for Aruba products, there's developer arubanetworks.com, DevHub arubanetworks.com. I'm using those resources to deliver this content. Get yourself an Aruba Central account. You will need it to have access to the Swagger interface and to the API itself. And if you're looking to learn a higher level programming language like Python, JavaScript, FLASK, whatever it is, udemy.com, affordable, and it'll ramp you up quickly. So thank you for joining this episode. We look forward to seeing you in the next episode of Aruba Restful Automation Series.